School exams.
Yeah.
Acha. So you didn't want it to class. It just sorry about that. Okay. ठीक है, तो स्कूल वाले ध्यान नहीं रखते क्या कि सैट का डेट कैसे मैनेज करना है?
I mean, no, everyone knows when it's gonna happen, and it's this information is available on like college board and everything also. So no.
ठीक है. Okay. So let's first finish that one question that we were doing. वो हमारा रह गया था पिछली बार. ठीक है, उसको जल्दी जल्दी में भी did like some blunders along the way. So let's do it properly today. And then we'll start with waves. Okay, जो कि basically तुम्हारी बुक में same ही chapter है, but it's actually a very different chapter from SHM. SHM is like the foundational element, and then wave, it kind of builds onto waves. So first this example. So the question was, there's a graph which shows, which is a velocity time graph of a particle executing SHM. Using the graph, have to estimate the area between the curve and the time axis from a specific duration. Then we had to state what that area denoted or represented. And then the last one is, I have to write down the equation of the displacement of the particle as a function of time. So let me just quickly make this. This is my time, this is velocity, starts at 0, this is somewhere -2, this is -4, this is +4, this is 0.2, this is 0.4. So I had to find the area of this. ये वाला जो section है, इसका मेरे को area निकालना है, ठीक है? So we came up with the solution, quite easy. कि यार सबसे पहले let's find out what is the equation, the velocity equation of this, right? And then we will just integrate it because the area we need is essentially that, right? So let's first find out Vt, velocity as a function of time. Now the general form, first I'm writing the general form so that we kind of get a sense of what we're looking at. This is the general form. Now the last time we did a lot of mistakes, but this time hopefully we will not. Let's first look at the amplitude here, which is 4, right? 4 is the amplitude. I'll use sine. I'm using the same things, but I'm essentially putting it in a different, I'm putting the values differently. Now omega, what would be the omega here? Omega is essentially 2 pi divided by t, and I see that the t is 0.4. Okay, so my omega will be 2 pi divided by t, which is 0.4. Now the question comes कि यहाँ पे ये जो omega है, is it the same omega that will be there in, say, my displacement as well? Yes or no? Yes? तो यहाँ से जो हम ओमेगा निकाल रहे हैं, would it be the same over there? Yeah, ठीक है. So that's why we can put it correctly. Like we don't have to change anything over here. Now, phi again becomes important because how do I check? How do I check what is the value of phi? I have to put the value of t as 0. Okay, so I put the value of t as 0, and the answer I should be getting should be -4. Now, because there is a minus sign over in the general form also, so I'll apply a minus sign here as well, just to keep it common. And the result is essentially that when this is 0, I will get a -4 if sine of phi turns out to be 1. That means what is the value of phi?
It should be minus pi by 2, right?
Minus pi. It could be minus pi by 2, it could be plus pi by 2 also. Either way, it will be +1 only. Now, yeah, either way it will be +1, but minus pi by 2 will be -1. जब हम ऐसे बनाते हैं, this is my theta, this is my sine theta, correct? ठीक है? So when my theta is pi by 2, my sine theta is equals to 1, right? This is 1, this is 1, this is -1, this is -1. So when my theta is pi by 2, sine theta equals 1. And when the theta is minus pi by 2, when the theta is minus pi by 2, because it's going on the other way around, then sine theta becomes -1. Okay, so we don't want that here, right? So that's why this will be pi by 2. See, trigonometry, a lot of maths is essentially an extension. मतलब इन सबको यूज करने के लिए हम मैथ्स बनाते हैं और फिर मैथ्स को यूज करके इनको आगे हम प्रूव करते हैं. So maths is a very there's a very interesting phenomena that kind of happens between maths and other sciences, which is maths is a pure science. Okay, what that means is maths का कुछ भी हम लोगों को दिया हुआ नहीं. We can't like find maths somewhere. Okay, it's a pure science. That means it's totally man-made. We have made it from the ground up. From this point that we say ki, okay, the number system, no one told us what numbers are. We made them up. Okay, and then from there we've come to such a degree कि हम calculus भी कर रहे हैं, ये सब भी कर रहे हैं. We've come to those concepts by our own thinking. Okay, so there can not be ever exceptions. मतलब exceptions बहुत कम होते हैं. Exceptions होते हैं तो they are well defined कि अच्छा यहाँ से यहाँ तक ही होगा. ठीक है. But in physics, chemistry, bio, or any other science, that is not true. The usual science जो हम लेते हैं, हम उसमें क्या कर रहे हैं? We are observing something and then we are trying to do something. Maths में उल्टा है. We are making something and then we are applying it somewhere else. In physics, chemistry, everything else, we are observing something and then we are trying to kind of analyze it using maths. ठीक है? So that's a very, very interesting dynamic that works. So इसलिए maths बार बार काम आएगा और इसको अच्छे से समझ में आना चाहिए कि क्या हो रहा है. Okay, so we're here. Now, first thing I notice is this, right? क्योंकि amplitude here for velocity. Now, A was the amplitude for my displacement. ठीक है? But the amplitude for velocity is A omega. So यहाँ से एक और relationship आ गया मेरे पास that A omega is equals to 4. And this is plus 4 because I'm using a minus sign already. Agar, if I didn't want to use the minus sign, okay? If I didn't want to use the minus sign, then I would write this as -4. Did you understand this? ठीक है? So, ऐसे लिख दिया मैंने. Okay? So this is one thing. यहाँ से मेरे पास omega की value आ जाएगी. So if I put the value of omega, which comes out as 20 pi upon 4, which is 5 pi. So I can just write this as 5 pi. And when I write this as 5 pi, my A becomes 4/5 ठीक है। तो ये सारी चीजें आ गई हमारे पास। इसको भी अब हम इसको इंटीग्रेट कर देते हैं। Okay, so let's integrate it. So now I can write all of these values, but I don't even need to write it. इसको बस अभी हम हटा के रख लेते हैं. Let's just keep it separately. That we know A is equals to 4/5 pi, and we'll integrate this from A to B. So time, this was 0.1 to 0.3. So 0.1 to 0.3. Similarly here as well. 0.3. ठीक है। अब कैसे कर रहे हैं, रिमेंबर हम कैसे कर रहे हैं, वी आर नॉट डायरेक्टली इंटीग्रेटिंग दिस, व्हाट आर वी डूइंग, हमने vt को कैसे लिखा, dx/dt लिखा, ठीक है, एंड देन ये dt हम इधर ले जाते हैं। नाउ वी कैन यूज, आई मीन ये जो सिंपल इस तरह के फॉर्मूला है ये वर्क करते हैं सिंगल डेरिवेटिव में, फर्स्ट डेरिवेटिव में, दैट्स व्हाई वी आर एबल टू डू इट। सो ऑन दिस साइड हम लोग क्या कर रहे हैं, इसका x का dx ले रहे हैं, x का इंटीग्रेशन कर रहे हैं, ठीक है। सो डिस्प्लेसमेंट का इंटीग्रेशन कर रहे हैं, विच इज द x दैट वी वांट टू गेट, और यहाँ पे विद रिस्पेक्ट टू t कर रहे हैं। ओके, सो हियर वी आर डूइंग इट विद रिस्पेक्ट टू t। ओके, अच्छा यहाँ पे ये जो लिमिट्स आएंगी ये भी गलत लिखी हुई हैं, क्योंकि these limits were for time। अगर मैं dx के केस में कर रहा हूँ, then I'll just have to write ab because I do not know what are the lower and the higher limits, ठीक है। So this is essentially just becomes b minus a whatever the value is। So यहाँ पे हम कर रहे हैं this becomes अब integration again, integration of sin theta d theta is essentially minus cos theta upon theta, ठीक है। सही है क्या, माइनस कॉस थीटा का साइन थीटा हो जाता है डेरिवेटिव, 1/θ का थीटा का 1 हो जाएगा, ठीक है। ओके, सो मैं यहाँ से ये कर दूंगा, this will become -4, this will become minus of cos 5 pi t plus pi by 2 upon this will be 0, this will be 5 pi. That's what I was thinking. This will be ये होगा। क्या ये समझ में आया? I change this क्योंकि if there's a constant with the theta then it will come like this। नहीं आया देखो समझ में। Okay, see what's happening। Essentially integration का जो simplest form है वो हम कैसे करते हैं, we have to, if we take the derivative of this, do we get this expression, this is how we do it। तो इसका उल्टा करना होता है कि यार how do I get this expression as a derivative of something, ठीक है। तो उधर से कर रहे हैं। नाउ cos थीटा का जब हम डेरिवेटिव लेते हैं वो माइनस साइन थीटा आता है, राइट, वो हमने ऑलरेडी एक बार कर चुके हैं, दैट इज व्हाई वी गॉट माइनस साइन थीटा फ्रॉम देयर, ठीक है। बट अंदर का भी एक एक्सप्रेशन है विच इज एन एक्सप्रेशन ऑफ थीटा, थीटा के केस में एक्सप्रेशन है, तो उसका भी हम वापस डेरिवेटिव लेंगे। उसका जब डेरिवेटिव लेते हैं, सो सपोज मैं cos ए थीटा का डेरिवेटिव ले रहा हूं, ठीक है, बाय डी थीटा कर देते हैं। इसका डेरिवेटिव जब मैं लूंगा तो क्या आएगा, माइनस साइन ए थीटा इनटू ए, वाई, क्योंकि ये ए थीटा का भी डेरिवेटिव होगा, ठीक है। सो दैट मीन्स व्हाट, अगर मेरे को सिर्फ a theta चाहिए तो I need to basically put a minus sign before cos a theta and उसके नीचे a लगाना. यही आया समझ में?
So when you get a derivative, then you would, and if there's a constant multiplying it inside the bracket, then you will take the constant and multiply it outside. That's what you did there, right?
Okay. Let me explain properly again. मैं थोड़ा सा jump कर रहा था because I thought you understood derivative and integration. Now, इसको हटा देते हैं, इसका काम हो गया है. अपन ऑलरेडी एक बार बात कर चुके हैं इसके ऊपर, बट आई एम अगेन टेकिंग सम टाइम बिकॉज ये क्लियर नहीं होगा तो बार बार दिक्कत आएगी. सी, डेरिवेटिव essentially means slicing into very small parts, right? Concept तो समझ में आ गया. Slicing into small parts. वो स्लाइस हम कैसे करते हैं, जो हम एक बार देख चुके हैं, which is limit theta tends to 0. अगर मैं ये लिखता हूँ sin theta, तो इसकी क्या वैल्यू आएगी वो मैं निकालने की कोशिश करता हूँ. ठीक है? So when my function is of this form, which is essentially that my variable is moving towards 0, that means the slices are getting smaller and smaller and smaller. What will be the value of this function, instantaneous function at that theta, वो मेरे को निकालना होता है. तो I write this expression in a smaller, shorter form as d derivative of sine theta with respect to theta. So basically, इसी को लिखने का एक नया तरीका है this. ठीक है? So इसको हम derivative बोल देते हैं because we use it again. That's why we call it. I mean, we give it a new name and call it derivative. Okay. Now, इसमें क्या होता है? अब मैं पूरा उसमें तो नहीं बता रहा हूँ, but sin theta का essentially आता है derivative comes out as minus cos theta. ठीक है? अब मैं पूरा बताऊंगा तो फिर उसमें काफी टाइम लग जाएगा. Let me just check if I have a better explanation for this, and we'll use that. ठीक है. I'll explain it in a better form to you. Okay. So this is not actually minus cos theta. Derivative of sin theta is cos theta. Derivative of cos theta is minus sin theta. Let me explain it in a more general form so that you understand it better. So what is happening? Suppose I have a function called y equals to fx. ठीक है? Now, a small change in x, I can denote it as delta x, right? It implies that there is a small change in y also. ठीक है? True for continuous functions. ठीक है? अब I'm not telling you what continuous functions are. Hopefully you already know that. But क्योंकि वो फिर that's a separate concept in itself. Okay? Now, essentially what I want to find is delta y, which is how much is this change? ये कैसे आएगा? This is essentially f of x plus delta x minus f of x. Make sense? Right? इसको हम लिमिट लगा देते हैं, इसके ऊपर हम लिमिट लगा देते हैं where delta x is tending towards 0, where delta x, oh sorry, इसको हमने दोनों तरफ से डिवाइड कर दिया डेल्टा एक्स से, सो वी गेट दिस, दोनों तरफ से डेल्टा एक्स से डिवाइड कर दिया तो वी गेट दिस, एंड नाउ आई पुट अ लिमिट in front of this where I say that this delta x is moving towards zero. It is getting as small as possible. Obviously, it's not equal to zero. Equal to zero होते ही तो ये not defined हो जाएगा, ठीक है? So it is moving towards zero. It is as close to zero as possible, but it's not zero perfectly. ठीक है? और इसको इसको हम लिख देते हैं, we write it as, तो ये लिमिट यहाँ पे भी लगेगा, delta x tends to zero, and this is what we call as dy by dx. ठीक है, इसको हम डेरिवेटिव बोल देते हैं. So essentially what are we doing when I'm trying to find the derivative of cos theta with respect to theta, where theta is the thing. क्या कर रहे हैं हम बोल रहे हैं cos of theta plus delta theta minus cos of theta upon theta, sorry, delta theta. ऐसे कर रहे हैं. And then we're trying to find the value of this where delta theta, d theta is going towards zero, which turns out to be, again इसका मैं पूरा explanation नहीं दे सकता हूँ, but it turns out to be, it comes out as minus sin theta. आया समझ में? ठीक है, so ये derivative ये होता है. Now integration क्या होता है? Integration is the opposite of it. जहां पे हम सेम ही चीज को दूसरी तरह से समझ सकते हैं. That I have delta y plus delta y plus delta y, and all of them, all of these sum will give me what? Y. ठीक है, essentially I'm trying to add those slices up to get my full pie. तो अब इन सबको मैं ऐड कर दूं, which is sigma d sigma delta y with respect to dx. ठीक है, sigma delta y with respect to dx. That means जो small change in y आया था वो x की वजह से आ रहा था. अब मैंने उन सारे changes को add कर दिया x के respect में, ठीक है, जहाँ पे exchange, जहाँ पे भी exchange हो रहा था, और इस चीज को I call integration of y dx. It's just a different form of writing. ठीक है, so इससे मेरे को area under the curve मिल जाता है in simple language. Now, how do I find what will be the integration of this? How do I find that? I basically suppose ये आ गया z, ठीक है, suppose ये z आ गया मेरा, suppose whatever I get is z as a function of x, ठीक है, क्योंकि सब कुछ function of x में चल रहा है, right? तो अब क्या होना चाहिए? When I differentiate zx, when I do zx का differentiation with respect to x, I should get y of x. इस तरह से मैं y का इंटीग्रेशन करूंगा. आगे समझ में? सो बेसिकली जो भी मेरे को इसका इंटीग्रेशन जो होगा उसका मैं रिवर्स जब करना चाहूं तो मुझे जो मैंने स्टार्टिंग पॉइंट किया था वो मिलना चाहिए. ठीक है, सो वही चीज हम यहाँ पे कर रहे हैं. सो फॉर दिस एग्जाम्पल हम क्या चाह रहे हैं? आई वॉन्ट साइन ऑफ ए थीटा डी थीटा, इसका मेरे को इंटीग्रेशन चाहिए. नाउ हाउ डू आई फाइंड दिस? इज एसेंशियली आई फिगर आउट कि यार अच्छा what would this be the derivative of, ये किस चीज का डेरिवेटिव होगा वो ढूंढना है मुझे. तो आई रियलाइज कि ओके, साइन थीटा किसका डेरिवेटिव है? कॉस थीटा का डेरिवेटिव है. कॉस थीटा को जब हम डेरिवेटिव निकालते हैं तो वो आता है माइनस साइन थीटा. ये मेरे को पता है ऑलरेडी. ठीक है, सो मैं क्या करूंगा? अगर मैं माइनस साइन थीटा को इंटीग्रेट करूंगा, अगर मैं माइनस साइन थीटा को इंटीग्रेट करूंगा तो मेरे को कॉस थीटा मिलना चाहिए, ठीक है। बट यहाँ पे माइनस साइन थीटा नहीं है, यहाँ पे साइन ए थीटा है। सो मैं यहाँ पे लिखूंगा कॉस थीटा जो माइनस है, क्योंकि नाउ इफ आई डिफरेंशिएट कॉस थीटा इट विल गिव मी माइनस साइन थीटा, और ये बाहर का जो माइनस है वो प्लस ऐड हो जाएगा एंड आई विल गेट दिस वैल्यू, ठीक है। आई एम स्टिल टॉकिंग इन थीटा राइट नाउ, ए मैं अभी लगाऊंगा नाउ। अब ये डिफरेंशिएशन का प्रॉपर्टी होता है वापस से कि जब इसके अंदर मेरा वैल्यू है, इसके अंदर भी अगर कोई फंक्शन है मेरा, तो मैं उसको भी डिफरेंशिएट करता हूँ, ठीक है, कि it's actually this into 1. So when I'm differentiating cos theta, what I'm doing is first I'm differentiating cos theta, और फिर I'm differentiating theta. ये याद आ रहा है क्या? ये सब हो गया होगा तुम्हारा शायद, है ना? So now this should be, अगर मेरा यहाँ पे a theta है, then I should have a multiplication of a here. ठीक है, तो इस तरह से ये a भी आता मेरा। When I take the derivative of cos a theta, this would be my derivative, final derivative. But now I do not want a as well, क्योंकि मेरा जो final, जो मेरा function है वो ये है, so I do not want a as well. So what I do is I divide this by a. ठीक है, so now when I take the derivative of this function, ठीक है, cos a theta का तो ये derivative आ जाएगा, minus and minus will become plus, and this a and this a will cancel out, in it eventually giving me sin a theta as the integral.
Understood, sir.
ठीक है, तो यहाँ से हम निकालते हैं। So once we get this, this is the value that we get. So वही चीज मैंने यहाँ लगाई है, sin theta का हम इंटीग्रल निकालने की कोशिश कर रहे हैं। So minus cos theta, and then इस फंक्शन का भी मेरे को इस फंक्शन का डेरिवेटिव जो है वो उससे डिवाइड कर दिया मैंने, ठीक है। So this becomes my this, और ये डेफिनाइट इंटीग्रल है, so from one point to another, ये t की वैल्यूज है। Got it?
Yes, sir.
ठीक है, so now what will be my final value of xt? -4 upon 5 pi minus cos of 5 pi into, I will put the maximum value first, so 3 upon 10 plus pi by 2 minus of cos of 5 pi 1 upon 10 plus pi by 2, like this. ठीक है, दोनों की वैल्यू डाली मैंने, पहले b डाला है, ठीक है, दिस इज b, दिस इज a, क्योंकि ये बाद में आ रहा है, या दिस इज द फाइनल थिंग, सो वी ऑलवेज डू फाइनल माइनस इनिशियल, सो वही किया है मैंने। अब इसको बस सॉल्व करना है। 4 upon 5 pi, यहाँ से क्या आएगा, this becomes 2, so pi by 2 plus pi by 2 हो गया, cos of pi हो गया, cos of pi कितना होता है, -1 हो गया, so -1 into minus becomes 1, so this becomes 1, so this becomes -1, so यहाँ पे -1 आ गया, यहाँ पे कितना आएगा 5, this becomes 2, 3 pi by 2 plus pi by 2, 3 pi by 2 plus pi by 2 is cos of 2 pi, cos of 2 pi is 0, cos of 2 pi is 1. Are you able to grasp it? Cos of 2 pi is 1, क्योंकि वो पूरा घूम के वापस इधर आ गया, 0 पे आ गया, ठीक है। So cos of 2 pi is 1, so this becomes -1, so ये -1 हो गया। ठीक है, ये ऐसे आ गया, सॉरी xt नहीं होगा, दिस जस्ट x, ये हमने वैल्यूज पुट कर दी हैं. This becomes -2 into this, so 4 into 2 is 8 upon 5 pi. This becomes my displacement. This is the area under the curve that we wanted to find. आ गया अब समझ में? ठीक है, so this is my area under the curve. The second part of the question was, what does it represent? It represents displacement, as we've just got. ठीक है, इसकी units क्या आएंगे? इसके units will simply be meters. ठीक है, because there is no time now.
So, no, it's fine. Because I remember it was centimeters or so, I think, maybe something like that. But yeah, the point is the units are going to be only in meter.
Yes, you're
Meters,
correct.
centimeters, yeah.
This is centimeters because the velocity that has been given to us is in centimeters per second. So this will also be in centimeters. Good. Okay. And then the third thing is, write down the equation giving the displacement of the particle as a function of time. तो अब मेरे को xt निकालना है. xt में कहाँ से निकाल सकता हूँ? इधर से निकाल सकता हूँ. I know everything over here. So my xt will become a cos omega t plus phi. Phi मेरे को पता है. अब मेरे को सिर्फ पुट करनी है क्योंकि मैंने ऑलरेडी सारा काम कर चुका हूँ मैं. ठीक है, बट आई कैन नॉट पुट 4 एज माई ए. माई ये a मैंने निकाला था 4/5 पाई, सो 4/5 पाई विल बी माई a. ठीक है, cos ओमेगा वाज कितना 5 पाई into t plus pi by 2. So this becomes my displacement का equation. ठीक है, quite straightforward once we got it right. पिछली बार काफी खोज कर दिया था हम लोगों ने. ठीक है, so perfect. Now let's start with waves. क्या होते हैं waves? What do you understand by waves so far?
Well, it's a way of transferring energy.
Okay.
Or in a way which energy
How
gets.
does it transfer energy?
Well, waves can be transverse or longitudinal.
Sorry?
So waves can be transverse or longitudinal.
Okay.
So the way those two differ is how the particle moves with respect to the motion of the actual wave.
Can you give me an example of waves?
Sound waves, light, those two, yeah.
Okay. So waves are essentially patterns or disturbances, okay, which transfer energy. Okay, that is the simplest way that you can say कि it is a disturbance or a pattern which allows physical transfer of energy. Or, I mean, just transfer of energy. It doesn't have to be always physical. Okay. So wave is a disturbance that transfers energy. Now, how is it different from SHM? Is it different from SHM first of all? जो भी हमने किया, is it different from that?
I mean, well, SHM had a restoring force. It was an oscillatory motion. And well, this is no, it's not similar to it because this travels in this travels in a certain direction, keeps traveling until it meets the wave.
The major difference here and SHM is stuck. That means it is only vibrating. It is only moving to and fro. There is no movement of the motion itself. ठीक है? So whereas in the wave, the disturbance itself. So SHM. Okay. So remember the question that we did last time, right? Which was essentially the wave was moving forward, right? I mean, standing wave थी. There was one point जहाँ पे वो move कर रहा है, but the points could be different along the string. You remember that question? Now, essentially, what was happening is every point on the string was basically behaving in an SHM manner. That means they were oscillating, and so they were performing SHM. But across the whole string, there were different amplitudes and there were different ways. Like the disturbance was actually traveling. Like to make it into a standing wave, it has to travel to the other end and then form the standing wave eventually. Okay. So that is the major difference of waves. So the particles in wave can have the SHM motion, and we'll learn more about it in the chapter. But the particles themselves, the wave themselves is moving. Okay. So the interesting thing here is the particles don't move. It's just the disturbance that it's just the disturbance that moves. ठीक है? So ऐसा नहीं है कि if okay, so let me give you an example of this. Um, have you ever been in this situation where you're in a train, okay, and you're in a bogie, and you're waiting? I mean, it's just standing still for a very long time, and then suddenly an engine comes in and it attaches to one end. Okay? What happens the moment the engine kind of comes in and attaches? There's a pushback, right? The first bogie moves, then the second one moves, then the third one moves, and then it travels throughout the train. And towards the end of the train, like even the last bogie will feel the motion, right? That is exactly what I'm talking about. So each bogie is essentially the particle where due to that initial energy, due to that initial push, that bogie started acting in a SHM manner, right? Because of that, it moved the second one, and then it started moving to and fro, acting in an SHM manner. But now that bogie, the first one, is still at its place. It hasn't moved. It just went to and fro, came back. I mean, it slowly came back to its original position, right? But the transfer of energy kept on happening till the whole train was covered. Okay, so that is what I mean by this, where the particles do not move. It is just that they transfer the disturbance or the energy forward. Okay, and that's what makes waves very different from SHM. Okay, so the particles may or may not behave in an SHM manner, but the wave is very different from it. आया समझ में? Now there can be a lot of different types. Lot of different types of waves. First is mechanical waves, which are essentially waves that require a medium. क्या मतलब हुआ इसका?
They need a medium which could be air, water, solid ground.
Why do we need that medium?
Because they're physical vibrations.
Yes, because the molecules or the atom in that medium are actually the vibrators, right? They are the ones which are moving, which are creating, which are in the SHM motion, and essentially they are the ones transferring the energy forward. Okay? So sound waves, water waves, waves on a string, all of these, the commonly seen ones are all mechanical. Okay? So they all need a medium. That means the moment if we go in, say, space, I cannot hear myself even, right? Because I speak something, there is no vibration. That means there is no molecules that vibrate. So there is nothing that reaches my ear. The only way that I can hear myself is if I close my ears and basically my internal bones are vibrating, and that's what I'm hearing, right? Otherwise, nothing from the outside is reaching my ears. Second is electromagnetic. And these are the ones that do not require a medium. Common examples are light, radio waves, X-rays, etc. ठीक है, these are the common examples. Light हम लोग तक पहुंच रही है because it doesn't require a medium. Now, the third one is very interesting, which is matter waves, which is essentially uh, particles showing wave-like properties. Have you heard of these? कभी सुना है क्या ये?
Actually, I don't think so. Not the term you used. Matter? Sorry, what was the term you used?
Sorry, matter waves.
No, I've not heard this term though.
Etc. So matter waves are essentially when the particles themselves start moving. So it has been hypothesized, and I think अपन 11th में तो नहीं करेंगे, 12th में जब रेडियो एक्टिविटी आएगी तब शायद करेंगे, where we learn about quantum physics. ठीक है? And quantum physics का basic जो फंडा है वो यही है कि यार these particles show both particle forms. That means they look like pieces, the discrete pieces, ठीक है, discrete bundles, as well as they work as if they are a wave property. They show wave properties as well. And wave properties का मतलब हुआ diffraction, interference, all of these things that we learn in this chapter. ठीक है? So वो दोनों चीजें दिखाते हैं, और इसीलिए बहुत टाइम से scientists were very confused that what is happening. They thought that there was either this or that. That means something could be only particle or something could be only wave-like. But now we realize, no, both of these are interconnected. Something which is discrete can also behave in a wave-like manner. So there came someone called D. Broglie. I don't remember his first name. So D. Broglie was essentially this guy who said, "Here, if this is true, if at a very small subparticle level, subparticle means electron, neutron, proton, ठीक है? क्योंकि हम particles बोलते हैं atoms, molecules को. So subparticle level पे if this is true, then this must be true at a macro level as well. That means a car is also showing wave-like functions. A human is also showing wave-like functions. Okay, so he gave this very famous equation, and I'm not going deep into it. If you're curious enough, you can find out by yourself. Where he gave this very fascinating, small, elegant formula, which says कि if you want to find the wavelength of anything, okay, anything in the world, you will be using this. Like they should probably be, they will basically follow this guideline. Okay, and he said that even before we could test it. That means we could not actually test कि अच्छा macro particles या matter waves are a thing. But he said कि okay, if matter waves are a thing, then this is what they should follow, and then he was proven right when we found out electron waves. Okay, so इसको de Broglie formula बोलते हैं. This is essentially the momentum, जिसको न्यूटन मोमेंटम बोल रहा था, मास इनटू वेलोसिटी. दिस इज प्लैंक्स कांस्टेंट. प्लैंक्स कांस्टेंट. ओके, So, and this is de Broglie formula. Now, yeah, de Broglie wavelength भी बोलते हैं उसको. So, इधर से हम लोग काफी चीजें निकाली. Using this, we were actually able to find something called electron waves. ठीक है? तो वहां से हमारा फिर once we figured that out, then we realized, okay, these two are connected, and that's when the whole concept of quantum physics kind of emerged from there. So electron waves जो होती है, electron, I think waves ही बोलते हैं, electron rays बोलते हैं, I don't know what they are called. वो सब जगह काम आती हैं. They are actually used like microscopes, electron microscopes होते हैं. They, I think, they are 1,000 times or 100,000 times stronger than the usual microscopes, and it is only possible due to these very high intensity electron waves. Okay, so quite something, but of course they are quite very expensive for us. So these are the types of waves. Matter waves is definitely one of the most curious and interesting things जो अभी तक हमें properly पता भी नहीं है. And if you've heard of string theory, then string theory का concept भी इधर से ही आता है. मतलब this matter waves से ही हमारे पास ये concept आता है string theory का कि यार if something is both a particle and a wave, then they should probably behave like a string, where a string can also it's like rubber, so it can both, when it's stretched, it can show wave like features, and when it's not, then it's just a normal solid looking thing. Okay, so it's not like this or that, it becomes both according to the different scenarios that it is put in. So that's the concept behind it. I don't know if it's true or not. It's still a theory so far. So yeah, so these are different types of waves. हम लोग obviously mechanical waves की ज़्यादा बात करेंगे, but most of the things that we'll be studying are also applicable to electromagnetic waves. Okay, but we would not be deep diving into electromagnetic waves right now. Okay. Now, next comes, there are other types also, which is essentially transverse and longitudinal. Longitudinal, I don't know how to pronounce this exactly. क्या होते हैं ये? Since you already mentioned them.
So I think the difference is in transverse waves, the motion of the particle is perpendicular to the motion of the entire wave, and longitudinal, it's with the
same thing. Yes. So transverse में क्या हो रहा है? If I'm making this graph, ये जो motion हो रहा है, this is of the particle. I mean, the particle is moving perpendicular to direction of wave. That means the wave is going this way, but the particle is going perpendicular to that wave. ठीक है? Longitudinal में मैं सेम डायग्राम बना रहा हूं, but now this movement is in the same direction as the wave. Now, the interesting thing is, even if ये दोनों अलग-अलग हैं, why have I made the same diagram? Or why have I made the same sort of a graph?
अच्छा वही सोच रहा था मैं. I'm not sure.
ये सही भी है कि नहीं है पहले तो? What do you think? What I've made is correct or not?
The second graph, the two arrows you've drawn are there to indicate the motion of the particle, yes? I mean, then I don't think it's correct because it should be like this, right?
Yeah. So it should be like that. What you've understood is correct. The particle is moving this way, and the wave itself is also moving this way. So each particle moves this way, and the wave itself is also moving that way. In transverse, what is happening? Each particle is moving up and down, and the wave is moving this way. ठीक है? Now ये तो जब मैं इस तरह का डायग्राम बना दूं तो सही था. But here in the graph, what is happening? I can represent both the scenarios in the same way. How? I will have to denote them differently. But I can show. So first of all, this is x now. This is not t. Okay? This is x. Why x? Because the wave is moving forward, right? So this is essentially the displacement of the wave itself. Okay? So suppose I'm vibrating, I'm going like this, or my hands are going like this, but at the same time they're also moving forward, right? So this is what is happening. So how do I show the forward motion? By x. Okay? And my y-axis becomes, for transverse, I'm calling it yt. For transverse, I'm calling it, let's just call it y for now, क्योंकि confusion होएगा अभी. Let's just call it y for now. ठीक है, तो यहाँ पे मैं y बोल रहा हूँ. Y essentially denotes कि ये जो motion है, this is perpendicular to the direction of wave. It does not denote anything, but मैं यहाँ पे बोल रहा हूँ कि this y essentially says that displacement perpendicular to wave.
Yes, I think I've got it. So the y-axis is simply denoting the magnitude of the displacement of the
Correct,
particle.
correct. तो यहाँ पे ये कितना मूव हो रहा है, कितना ये ऊपर नीचे जा रहा है, वो मेरा y एक्सिस बता रहा है. आया समझ में?
And then you specify on the y-axis whether it's perpendicular to the wave's motion or along.
Yeah, I mean, I basically use a variable and then define what that variable means. That is what definitions are for. In this context, even though I'm using the same graph and they look similar, they are not. That is the reason I've made this in front of you. ठीक है? क्योंकि बच्चे इसी में confuse हो जाते हैं आज से ज़्यादा time. So here, now look at this, the longitudinal one. What is happening? I cannot, if I've defined y as my displacement perpendicular to the wave, I cannot use the same variable here because then it will be wrong. So the variable I use here is s. Again, I can choose any random variable. I have chosen s. Okay, and I say that s denotes the displacement of particle in the direction of wave. Okay, so now I'm showing this. Okay, how much is the particle vibrating in the same direction as the wave? So यहाँ पे भी वो amplitudes ही दिखा रहा है, and obviously all the middle things. But now here it is showing how much is it moving forward and backward. आ गया समझ में? ठीक है? This is a very very important thing क्योंकि यहाँ पे बहुत confusion होता है. Okay, now क्योंकि ये वाला जो difference है, this will be used again and again, and this difference also tells us कि what kind of mediums can handle transverse or longitudinal waves. Okay, so transverse waves are possible only in mediums that sustain shearing strain. Do you know what shearing strain is by any chance? Shearing strain is essentially, suppose I have a box or whatever, I have, say, something flexible enough, and I push it without losing its feet, okay? Without losing its feet, the thing goes, I mean, thing is able to move, it is a little flexible, and then it comes back, okay? These are elastic properties. Part of elastic properties of the medium. So what is happening? If I have an object and it can basically sustain some sideways force without moving, ठीक है, पूरा का पूरा move नहीं कर रहा है. So someone say pushes me from the back, I can move two ways. Either I move forward itself, or just my upper portion goes and then I go back. Right? So when this happens, when I'm leaning, that is what shearing strain is. ठीक है? So shearing strain in simple words is ability of body or object or medium, whatever, uh, to um, to come back, ability of a body to sustain a sideways force and ability of a body to sustain a sideways force and then revert back to the original shape. उसको हम shearing strain बोलते हैं. ठीक है?
And the velocity remains the same of the object.
Yeah, velocity is not changing.
Right, okay.
It is essentially, see, we are not talking about velocity anywhere. We are only talking about the property of the medium. Elastic property. Let me explain what is elastic property also first. Elastic property of any medium or any object is essentially the ability of that object, to recover when it is deformed. ठीक है, किसी भी तरह से हम डिफॉर्म कर रहे हैं, चाहे से हम उसको पिचका रहे हैं, चाहे से हम उसको पुश कर रहे हैं, चाहे से हम उसको कुछ भी और कर रहे हैं, whatever are the forces that are possible. ठीक है, what is the ability of that object to recover from that deformity? ठीक है, write this down. This is important. These are things that are not in your book. ठीक है, आधी से ज्यादा चीजें तेरी बुक में नहीं है. And if you open your book, you'll be super confused because there are so many things. By the way, I'm still not very sure about the syllabus that you guys have in 11th. क्योंकि जो, I mean, I think अपना जो पहला डिस्कशन हुआ था वो था कि 6th या 7th चैप्टर तक आ रहा है, बट उसमें काफी सारा तो मतलब जो 12th वाला हो गया फिर that becomes very small. That means the remaining of the book is quite a small portion.
Okay.
That's what I am thinking.
I have the book right here.
स्कूल में हो गया ना apparently.
हाँ, school में तो he's done it, yes.
He's done the entire syllabus.
No, not the entire syllabus. He's finished waves, finishing waves.
I'm asking for the entire syllabus because I'm still a little confused over there.
No, he's not done that yet.
तो अभी clear नहीं है क्या तुम लोगों को? You guys don't have like a list of chapters that you will be doing?
No, he doesn't.
ठीक है. Try. I mean, if you attend your school classes, check if someone else knows probably, or
Sure.
if you can ask the teacher itself.
Yes.
Himself.
Okay.
Okay. Okay. Let's come back. So elastic property क्या बोला मैंने कि essentially it's the ability of the body to recover from a deformity. Okay. इसी का एक और aspect होता है. ये था shearing strain. See, the word strain is essentially again used for a purpose, which is when we are forcing something to just how do we use the word strain in English or like in day-to-day language, where we are trying to strain our muscles in a sense, right? I am not able to put it into correct phrase here.
Strain, you could say could be the ability of an object to sustain a certain force. You would use strain and say like hanging bridges. How much strain can the what do you call those? The wires.
So I mean, when we talk about bridges, then we are actually using the physics term only. But yes, okay, it's essentially the same thing. Ki how much force you can handle without deforming, without changing your whole properties. Okay. So the other form, and that will be used in longitudinal, is compression strain. Compression or compressive strain. And which is straightforward. When I compress something, that could be a string, that could be something else. Okay? When I compress something, the ability of the body to sustain and recover from that compression, okay, to its original shape from that compression will be called compressive or compression strain. That means इसके examples क्या हुए फिर? Possible mediums that can sustain shearing strain are string, water, solids. ठीक है? Mostly it'll be solids and a little bit of liquids. But gases में तो possible ही नहीं है. ठीक है? Because gases में the deformity will be huge, right? Because if I push some gas, then it will just vanish. I mean, probably I cannot even push it or put a shearing strain on it, right? At the same time, longitudinal में longitudinal, I mean, correct the spelling, whatever it is. It essentially is possible only in medium that can sustain compressive strain. Okay, so the possibilities of that are solids, liquids, and gases as well. Because all three of them can sustain compressive strain, right? I can compress a solid as well, like I can compress a spring, for example. I can also compress, say, when I'm essentially hammering a metal plate or like a metal box, what is happening? I'm essentially compressing it, right? For that moment, for that short, brief moment, I'm compressing it. So that is also a form of longitudinal compression, or sorry, compressive strain, which forms longitudinal waves in the solid. क्या है समझ में? ठीक है? Liquids and gases, of course, ठीक है? We see that already. Gases के अंदर, gases is sound that we have, right? So वो already हो रहा है. Liquid के अंदर भी ये possible होता है. So transverse waves are only possible in certain mediums. Now, why is it possible in shearing strain? Because of tension. Usually this tension that is available. Okay? So when I'm using a string, okay, when I whiplash a string or something, what is happening? Each part of the string is pulling other part of the string back. the restoring force is coming from the tension amongst the string. ठीक है, इसलिए it is working. That's why we need the shearing strain. ठीक है, यहाँ पे वो gap आ रहा है. There's like a compressive gap that gets created, जिसकी वजह से हो रहा है. Obviously, there are possibilities that transverse and longitudinal waves are present. Both of them are present in the same medium as well. That is also a possibility, right? And the simplest example of both of them is water waves. Okay, let's see what water waves are. Water waves are two types. One is capillary. This is just like a side info type in case कोई पूछ लेता है तो. Capillary waves. Capillary waves are the ones that you see when you drop a stone. Okay, so when you drop a stone and the ripples that are created, those are capillary waves. Okay, so these are short waves or waves with short wavelengths. Waves with short wavelength of usually centimeters to a few meters long. Okay, now this is again, at least in my imagination, when I think of waves, or at least when I used to earlier, what I used to think was waves की जो wavelength होती थी वो बहुत ही छोटी होती थी, right? That's what my imagination was earlier. Do you also think that right now?
Like these capillary waves.
No, I'm saying कि in general, when I was thinking of waves earlier, okay, not now, but earlier when I was a student and when I basically got introduced to all of this initially, I had this feeling that waves only had wavelengths of very short amount. Short in the sense micrometers or really small, tiny things, जहाँ पे मेरे को दिखेगा ही नहीं.
I mean, I never really had like a like a. No, I don't really think I don't think they're small or big. I mean, they're all possible. And there are
Yeah,
examples
there
in
are
our day-to-day
possible.
life.
Yeah. So what I'm saying is, I never really saw it around me. So when I first got introduced by waves was essentially either in physics, like this what we are studying, in sound waves. So like in sound waves, when we talk about waves, obviously we cannot see those waves happen, right? And when they are happening at say 330 meter per second speed, obviously the wavelength will be quite small. For a sound wave which is moving at 330 meter per second, उसका वेवलेंथ काफी छोटा होगा, ठीक है? I mean it depends, pitch के ऊपर depend करता है वो.
Okay, fine.
We'll come to that, ठीक है? So, but it's quite small. Okay, anyways, that was the like a very bad segue. So, capillary waves are essentially in this, and then other form is essentially something called gravity waves, which have wavelengths of tens or hundreds of meters. Okay. So यहाँ पे this is caused by drop of the stone or like pair. I mean something goes into it or something like that. Gravity waves happen due to the force of gravity. ठीक है? These capillary waves sustain due to surface tension of water. Right? So when we are dropping a stone, what is happening is we are disrupting the surface tension of water, and because of that, these capillary veins are waves are formed. पता है कि तुझे surface tension क्या होता है? पूछेगा कौन फिर? Surface tension is very similar to how the tension on string works. So क्या हो रहा है? Every particle on water, suppose I have like this jar of water. It's a very interesting phenomena. Again, this is like the classical example that physics and chemistry are not very different. They kind of everything is connected at the end of the day. Suppose I take these three particles, right, and I take one this. So I'm just comparing, say, one particle on the surface and one particle in the middle. The particle in the middle is getting pulled from all directions, right? Because there are other particles which are attracting it from all directions. But the particle at the surface is only getting pulled in this way, right? यहाँ पे no one is pulling it upwards, right? So that means what? This particle is not balanced. This particle is getting pulled again and again in the water by its fellow friends or fellow particles, right? And each particle on the surface has the same exact behavior where it is getting pulled down and down and down and down, right? So the side particles, so ये जो दो particles पास में ये भी एक दूसरे को रख रहे हैं आसपास में, ठीक है? They are also keeping it together, which causes a tension. Essentially, all of them are making a chain with each other, and if one of them also moves, all the others will also move. You understand? So it's like playing that game. वो पहले हम बच्चों में खेलते थे ना, chain बना के जो खेलते थे. I don't know what it's called in English.
Dominoes. I think
I
that
guess.
like okay, yeah.
Basically, you make a chain and then you try to catch other people and you make a bigger chain. Okay, slowly the chain gets bigger. Now, essentially, what happens over there is, even if, so if I'm in a chain with, say, 5 people, even if one person moves in that chain, automatically all the others will also kind of get an effect of it. Right? It's very simple, and you can also imagine it. So that is what? That is an example of surface tension. Okay, that is the example of surface tension, where all the others are, you move because of the others that are moving around you. So surface tension in water is also similar to that. Okay, so when I disrupt some, even a single particle over here, suppose I put a stone, momentarily what will happen? This thing will go down. जैसे मैंने stone डाला, for a moment, this thing will have a dip, right? And because of that dip, all the rest of the things around it will also suffer, and then they will start showing the ripples, the waves. Okay, so that's how the capillary waves are created. Got it? Okay, quite simple to understand. And gravity waves are caused by the gravity of the moon usually, right? जो हम tides बोलते हैं जिसको, वो उसकी वजह से होता है. ठीक है? I mean gravity of Earth की वजह से भी होता है, but mostly it is of the moon, right? High tide, low tide जो बोलते हैं हम, वो इसकी वजह से आ रहा है. Okay, so this is due to the gravitational force of both Earth and Moon. Okay, so this is an example of both longitudinal and transversal. How?
So the capillary waves. Okay, how could this be longitudinal and? Okay, I'll think about this.
They are not ऐसे नहीं, surface वाले पे नहीं है, ठीक है? So the waves that you see on the surface are just transverse.
Okay, I understand this now. So capillary, like you just said, key surface pe it's transverse, and I'm guessing what's happening below the surface There
Yes,
must be
that is
some
very strong.
disturbance, right?
Okay. So in both the cases, the waves are not just on the surface. Surface पे तो हमें दिखता है. But the effect of both the things, be it a stone, be it gravity, affects the whole body of water around it. And so there are waves which are formed inside the water as well. Okay. Obviously, the effect kind of diminishes very quickly beneath it क्योंकि medium change हो गया, right? ऊपर जो है थोड़ा surface ज़्यादा होता है और हवा रहती है इसलिए हो जाता है. But the waves are also there in the inside the medium, right? So if you go into a swimming pool and you see, like if you felt that where you're in a swimming pool and someone dives or someone jumps, you will see like a gush of water like coming towards you, towards your abdomen or towards your legs as well. Like what is that? That is longitudinal waves. Got it? Okay. So both of them happen. But now the important thing comes in. But speed of transverse, speed of transverse and longitudinal in the same medium सेम रहेगी डिफरेंट रहेगी क्या
Um,
लगता है सेम रहेगी डिफरेंट रहेगी
I mean, why would it be different or same? Uh, I mean, if I go by example, sound,
हाँ
sound which is longitudinal, it's quite fast. And if I think of disturbances, transfer disturbances, I think longitudinal would be faster. I'm not sure, but that is my guess.
So I cannot say which one would be faster or slower because it totally depends on the medium that we are talking about. Okay, that is the first thing. क्योंकि अगर हमें medium ही नहीं पता तो हम कैसे बोल सकते हैं ठीक है For example, say I take a wire. Okay, now I take a really flexible wire, obviously made up of metal. The sound through that wire is a longitudinal wave, right? So if I basically think of this, that aluminum cup thing जो एक बचपन में हम लोग बनाते थे ठीक है So they are all physics का concept, right? So they are all based on the same thing. So essentially what we do is we speak into a can and then it transmits, the wire kind of transmits it. Now when I speak, the sound gets converted into the vibrations converted into sound. Sound then it reaches the wire and the vibrations start happening in the wire. And that is a form of longitudinal wave in the wire. Yes? Yes? And at the same time, if I move the wire like this, okay, I start moving the wire like this, that becomes what? Transverse wave. And the same one. Which one would be faster? Obviously longitudinal. Obviously longitudinal. If I'm speaking into it and someone can hear it in like an instant, obviously that's a lot faster than say I'm moving it up and down and then getting there, right? So speed of longitudinal would be faster in that case. But say if I change the medium to liquid, okay, say I change the medium to liquid, now sound in water becomes difficult to pass, right? At the same time, uh, the water waves could be faster. Again, I'm not sure how it would be, but according to the medium, it will change. You understand that? But what you can see in both the cases, they are not the same. Okay, the speeds of transverse and longitudinal are not the same, and so the speed of transverse and longitudinal waves in the same medium will be different. Okay, they will not be equal, they will be different from each other. Okay, so that's it for today. आज अपन ने एक तरह से थोड़ा brief introduction theoretical ज़्यादा किया है. Next time we'll do like the wave function किस तरह से derive करना है. That will be a lot of fun. I didn't want to cover it today because फिर वो HG miss कर देता तो difficult होता. ठीक है, अगर वो अगली बार भी नहीं आता है then we'll obviously cover it.
Man, he'll come next time because SAT's gonna be over tomorrow.
हाँ, I'm sure. I'm just saying in case होता है तो.
Okay.
ठीक है. Sure.
All right, sir. Thank you.